Having difficulty with SLAM on an AMR, losing localization in a manufacturing area that changes drastically hour by hour due to pallets and carts movement. Is there inherent weakness with SLAM? So I guess that goes to you, John.
I think it's a real challenge. So the issue of how do you map dynamic environments? One of the things in robotics, like my advisor, was wonderful friend, Hugh Dornt-White, my mentor, he said we solved SLAM back in 1991. And I was like, no. And I think there's still a lot of fundamental work to be done. So, but dealing with like construction or dealing with changes in a factory, those are very real challenges. And I think there are promising techniques, but just be careful if you're the customer to ask the right questions, that the world's going to change.
So I guess we'll make the websites or the web pages available. But
it's SDAG.
You give them the mic. Yeah.
It's sdag.ccl.mit.edu.
Okay. So tactile sensors such as wired gloves or piezoelectric materials demand advanced AI chips to accurately sample the analog signal and process with machine learning. How can we improve machine learning chips embedded in gloves? We'll check that yours. Oh, here we go.
All right. I think that this is quite interesting, and we frankly haven't looked at this. I think there's a lot of these chips are currently even offered in the cell phones. So potentially, I think that there's definitely potential to do a lot of to have this kind of chips that perform this type of analysis. And I want to mention that the data is very similar to typical data that you get from images and videos, and typically the resolution is lower than the data from images or videos. So I would say that the same types of architectures could be reused in both cases.
So I want to ask a question that's not up here to Fox. In terms of, as you look at sort of new technologies, whether it be in AR and VR, I mean, do you see that as being a unique opportunity because of the technology, or where we are societally to sort of try to improve the recognition of the diversity that we have in people and experiences, and try to reduce some of the issues that we have with discrimination?
Well, certainly I think that there are some unique opportunities in terms of the technology. One of the issues is that a lot of the latest work that addresses modeling social issues, such as taking on a particular gender in VR, or a particular ethnic background and so forth, really does it at a rudimentary level. It just uses the body as a surrogate for all the kind of real-world experiences of those categories. And so instead, what we'll try to do is model the systematic phenomena. So you'll find sometimes some study that will look at just what's the difference of behavior change based on having a different virtual body, as if all bodies of a certain kind of category are the same. Instead, for example, let's take our work on modeling racial and ethnic socialization. We're looking not at what the avatar looks like. We actually use empirical metrics for how people have been socialized to think about race and ethnicity. That is, do you think about it as something which, are you distrustful of other groups? Do you subscribe to a kind of colorblind ideology and so forth? We'll measure this, and then you could say people will see the same exact scenario very differently on how they think about this kind of social issue. Similarly with the work on sexism, it's not just about using a female avatar in the situation. We're actually taking the latest social science model of sexism and implementing the systematicity of that kind of model. And I think that's one of the great things that these kind of technologies can do, is provide, and this relates to, I guess, this question with 6 votes here. It relates to this kind of issue that you actually can play through the same scenario multiple times in a kind of low-stakes environment. It's not something that's then being reported on you. It's not in this situation. And it's also not just pointing the finger at you and saying you are sexist. It's showing the kind of outcomes of that kind of behavior within that scenario, so you can think that through. So that's just one advantage of doing this in a simulated environment as opposed to a kind of physical world environment. And then finally, again, we're using validated instruments doing empirical studies. That means these instruments have been shown as far as you can with self-reported data to actually measure what they say they're going to measure.
Let's see, you go with the top vote here. What about open innovation in VF autonomy, VR, I think, autonomy, if the behemoths, Google, Apple, Facebook, acquire and shield the latest and the greatest? I guess that's for everybody and anybody.
That's a scary one. I can say I'll tell you the story of my student Ross's startup, Escher Labs, that this doesn't necessarily answer the question, but it shows how quickly the movements are in this space, that he kind of did the startup with $25,000 of sandbox funding in the 6th year of his PhD when he was drifting a little bit. And then he applied to do the sort of startup boot camp in California, YC. And then he went to YC, and then they did very well. And I think by October, they were acquired by a big player. So I think I would almost reinforce the question that if there's a promising new sort of approach to sort of, say, getting multiplayer, AR, VR, that you're acquired in 12 months by a big company, that is kind of scary to me in terms of, so on the flip side, I would say I always feel there's a place for like professor plus 7 grad students plus a postdoc in an academic setting to just come up with that new thing that industry's not thinking of. I think there's something still special about academia that problems people think are solved and, oh, industry's going to take care of that new methods still come from academia. I guess the question is what happens in between.
Yes, I would like to echo that I think that academia and startup ecosystem can play a very important role. And I think here, within MIT, obviously, we try to do best in these areas. I don't know, that's about it.
Right, I mean, I think similarly, I mentioned one of the back-end architecture for one of the systems that I mentioned was patented. I mean, I'm always gratified to, sometimes I have students that go off and work at AAA game companies, and they'll say, you'll be happy to know that the latest system for representing avatars in this one, it does such and such in a more ethical way than the previous iteration of the prior system. So it was also just great to see that both the kind of innovation, students are entering the innovation economy, but also they're being trained to think about these issues in a kind of critical and ethically sound kind of way.
So you have 4 votes there. So adaptive storytelling, what other applications of this interactive technology can you envision and are you looking forward to?
Well, there are just so many kind of applications. So I mentioned one, making video games more compelling, but also modeling social issues. I mean, so even the most maligned kind of games, people talk about a game like Grand Theft Auto. I've heard it referred to as the birth of a nation of video games, right, in some ways. But at the same time, it actually does have social commentary in it, but it's not built into the game mechanics. I think for training, that's another kind of area. We've used virtual identities for STEM learning. That is, if you have an avatar standing in between yourself and computer science learning, there's a well-known phenomenon in social sciences and learning sciences called a stereotype threat. That is, people perform up or down to the stereotypes about them. That is, if you have, for example, a female computer science student as a high school student, and you just have a checkbox for gender before taking the test, then she actually performs worse on average on the test than if you didn't have the checkbox because of the prevalent social stereotypes that are being triggered. We've actually shown you can mitigate against these kind of effects using virtual identities. When you're doing well, you have no avatar, or you have an avatar that looks like you. When you're not doing well, then you can just pop up a kind of box for feedback and so forth. So we've actually done crowdsourced studies of over 10,000 users to show the best cases for using virtual identities for learning. Journalism, we're doing a project on deep fakes and education around deep fakes just now. So there are just so many kind of applications related to interactive storytelling that I think are critical. And finally, I'll just say you can also reduce costs too. Rather than having to write branching dialogue, which is exponential growth, if you can trigger different dialogue based upon tracking users' trends within an experience, then you've also reduced the kind of overhead of writing for these kind of systems.
You wanted to go to the one, there was one on how well, so how well is the biological sense of touch understood? Are there any parallels in your piezoelectric implementation?
I think the biological sense of touch, has been studied quite extensively, and people are looking at, obviously looked at in a very detailed way how different kind of mechanoreceptors work. I would say in general, they work quite well, quite differently from piezoelectric implementation. So I think, I'm not sure if the parallels are very strong in this area. So the question potentially is, how can we potentially build better, more biologically inspired sensors? Well, I think this is whole sort of research areas, and I think this is I find the whole area quite exciting, and incorporating different types of. So in this particular project, we looked at the very, I would say, the simplest way of looking at touch reception and perception, and only looking at the pressure signal. I think that, for example, you can look at things like tangential forces. You can look at temperature sensing and so on. So there's way more to do in order to really understand, how touch in general works for humans. So and development of more general sensors, I really think, is a very fascinating area, especially in the if you would like to do it in a bio-inspired way.
So I'm going to go to the first one, 3 votes. I have an intersecting question I want to ask as well. But in the multimode driving model, where humans and machines are both driving vehicles on the same road, is it more likely that humans will bully the machines, and how can this be resolved?
Yeah, well, bully is a strong word, but I think it's definitely possible. And I think you can imagine, teenagers encircling an autonomous car and sort of, as like teasing almost, or just to stop it. But the interaction of humans and autonomy in general is really a critical area, and we want to hire faculty in that area. So I think there's a whole future. I think these issues are not going to go away. They're going to actually only increase. But if you want a very specific context, in the last 48 hours, a bunch of videos came online of Tesla's new summon feature, which terrifies the heck out of me. They have people using their cell phones to summon their cars in parking lots, and already some little accidents and close calls, and some social things between like 2 cars in a parking lot where one doesn't actually have a driver. So it's worth Googling, but I'm scared by that world.
What's your prediction when are we going to have self-driving cars?
Let's say from MIT to Logan Airport, fully autonomously with no driver, for me it's at least 10 years away. And with any weather conditions, maybe 20 years away. But I'm a contrarian, so.
Is there any opportunity to understand sort of in the sort of mixed mode of human driving, but sort of like when you're gripping the steering wheel in panic, is there data that can be gleaned, anything that would be helpful in sort of an intersection between that pressure on the steering wheel and
I'll just say that the issue of driver monitoring systems is a great thing. So Tesla uses a force, your steering wheel torque, which folks have argued about how reliable that is, and Cadillac Super Cruise has a driver monitoring system camera that's really very performant. It works really well. But that whole issue of interacting with the human, and then the privacy issues, and it's a sort of brave new world in some ways.
do you see utility of grayscale in real-time journalism in covering current political discourse in the U.S.?
Well, it's a great question, but first, I'll just clarify that the patented system is Chimera. That's the platform, so that's the generalizable model. Grayscale is one particular kind of implementation using our platform, which is about sexism in the workplace. And so with the system Chimera that models social identity, the aim is to capture more of the kind of nuances, that it's not just, our social identities are not just described in a taxonomic way, where you have some set of features that puts you in one category. And I think we can actually find consensus using this. So for example, I've actually run workshops where people have simulated some issues around political debates. But to give one example, imagine issues around sustainability, where you have both ranchers that believe in stewardship of their land, as well as ecological activists that also believe in stewardship of the land. But when you think about filter bubbles and so on, there's not going to be consensus that's going to be found. But if you can actually model the commonality and present these in a similar, and model that commonality in a similar kind of way, and stage the articles in a way that's amenable to each group, then you might actually be able to find consensus. And that's the sort of thing that I'm interested in using the Chimera system for.
Okay, let's see. I think we have about 2 more minutes. Trying to get a question here that sort of covers a bit. Go ahead, John. Yeah, please.
Can I ask Fox a question?
Please, absolutely.
From my experiences in Silicon Valley, increasing diversity in the workplace is a huge challenge. And could you imagine like a completely virtual interview screening process whereby it's, the social identity cues are abstracted away and allows a truly fair interview process to happen, at least at the screening stage? Have folks doing that?
I've heard this idea, and some places actually are doing this. I think one of the challenges, though, it makes me think, there's the famous cartoon, at least in media studies, where you have 2 dogs at the computer, and they're saying on the internet, nobody knows you're a dog. And so that's seen as this great thing, that this anonymity. But the critique of this is that, that what if who you are actually matters to you when you're online and having to obscure it? And so one of the things that we're interested in is, so like for example, the work we used a variety of machine learning techniques in the Middle East to find what are the kind of trends in use of these systems, especially related to privacy, modesty, and so forth, basically categorizing clusters of different types of use, working with social scientists to then characterize these kind of clusters. So then you can design the systems specifically for the needs in the with the region in mind. So certainly I think there's some ways you can abstract your identity that's useful, but even better is responding to the particular kind of social needs and values being negotiated.
So I think with that, I'd like to thank the panelists and the speakers.